Incidence rate, also called incidence density or simply rate, measures how fast an event is occurring in a population. To calculate it, divide the number of new events that occur during a time period by the total time of follow-up or person time. So what is person time? Let's look at an example. Suppose the event of interest is the development of some disease, and our study followed 4 individuals. The first developed the disease after a period of 2 years. The second was followed for 5 years without developing the disease. The third died after 2 years, and the fourth entered the study in year 2 and was lost to follow up a year after that. Person time is the total amount of time over which all these individuals were at risk. So the first person was at risk for 2 years before developing the disease, the second person was at risk for 5 years, the third for 2 years, and the fourth for 1. The total is 10 person years in this case, and since only 1 person developed the disease, then the incidence rate is 1/10, which is 0.1 case per person year or 1 case per 10 person years. So we can say that a person is expected to develop the disease after 10 years of being at risk. Now let's take a closer look at the formula for calculating rate. The numerator is the number of individuals who did not have the disease initially, but developed it sometime during the follow-up period. The denominator is the portion of follow-up time contributed only by individuals at risk. These are individuals who do not have the disease at the start of the study and who are susceptible, and therefore capable of developing the disease over the follow-up period. The incidence rate ranges from 0 to infinity. 0 means that no one developed the disease during the follow-up period, and plus infinity means that everyone developed the disease instantaneously at the start of follow-up. Incidence rate takes into consideration different follow-up periods of study participants. So participants who enter or leave the study at different times during follow-up will not cause any problem when calculating the rate. But if the incidence rate measures the speed of occurrence of an event, what would happen if this speed changes with time? Take surgical site infections, for example. Most of them develop during the first month after surgery, and then the infection rate decreases dramatically after that. In this case, if we calculate a single incidence rate of infection for the whole period of 2 months, we get a single number, the average rate, that does not reflect the early peak and the late drop in the curve. Instead, we can calculate 2 incidence rates. The first one is the rate of infection over the first month after surgery, and the second one is the rate of surgical site infection after 1 month of surgery. These 2 numbers will be better than 1 at summarizing the incidence rate of surgical site infection. Thanks for watching. See you in the next video.